Hello everyone. In this video, we are going to see a problem in power electronics. The question is the single phase rectifier consisting of three thyristors T1, T2, T3 and a diode T1 feed a power to a 10 ampere current, constant current load. T1 and T3 are fired at alpha equal to 60 degree and T2 is fired at alpha equal to 240 degree. The reference for alpha is the positive zero crossing of V in. The average voltage V0 across the load in volts is dash round off to 2 decimal places. This is a numerical type question. We have to solve this question and fill the correct answer. Now we have this single phase rectifier circuit in which out of the four devices we have three thyristors and one diode. And the rectifier, it is feeding a constant current load. Now for this circuit, first step is we need to plot the output voltage waveform. Once we plot the output voltage waveform, we can find out the average output voltage. Now for plotting the output voltage waveform, so initially it is given that T1 and T3 are fired at alpha equal to 60 degree. So which means that during the positive cycle, T1 and T3 are forward biased, and T1 and T3, since they are fired at alpha equal to 60 degree, they can start conduct at alpha equal to 60 degree. So from alpha, that is from 60 degree, T1, the current will flow from the source through T1 through this constant current and then through T3 and back to the source. So V0 will be following the input voltage V. That is 100 sine and omega t. Omega is given here as 100 pi. So output voltage will follow the input voltage as such when T1 and T3 are conducting. At pi, when the diode T1 and T2, they are forward biased. So as soon as the diode D1 is forward biased during the negative of cycle, this T1 will start conduct along with T3. Since current is still 10 ampere, T3 cannot be turned off because of that we will be having the freewheeling action taking place by the diode T1 along with T3. So now at pi, until the T2 is triggered, though T2 is forward biased during the negative half cycle, that will start conduct only at 240 degree, that is pi plus alpha. So until that, T1 and T3, they will provide a freewheeling path for this 10 ampere current. So during that time, V0 will be equal to 0. Again, when T2 is triggered at 240 degree, at that time T3 will be turned off, and so we will be having the current flowing through D1 through the current constant current load and through T2 and back to the source. And during that time, V0 will be equal to minus Vm sin omega t, because during that time the negative side of the input voltage will be brought on the positive side. So and at 2 pi, we will have, since the current is still 10 ampere, it is not reaching 0, T2 will not get turned off. So T2 will be continuing its conduction along with T1. So we will be having the current path that is flowing through T1 and T2 until T1 and T3 are fired again at 2 pi plus alpha. So until then, the V0 will follow the minus Vm sin omega t. So the waveform will be this one. So from alpha, that is 60 degree, to pi, T1 and T3, they are in conduction. During that time, the voltage will be following Vm sin omega t. From pi to pi plus alpha, we will be having the conduction that is taking place by D and T3 and D1 will be in conduction from pi to pi plus alpha. So during that time, since freewheeling action is taking place, output voltage will be 0. Then from pi plus alpha, when T2 is triggered, T2 and T1 combination will conduct. So the output voltage will be the mirror image of the input voltage, which is minus Vm sine omega t. So this combination will conduct until your T1 and T3 are fired again at 2 pi plus alpha. So this is the point where we'll be having the conduction of T1 plus T1 and T3, which will be taking place at 2 pi plus alpha. So this is the output voltage waveform. And for this output voltage waveform, we need to derive the V0 average, which can be found as 1 by 2 pi alpha to pi. We have Vm sine omega t, d omega t, plus integration from pi plus alpha to 2 pi plus alpha. We have minus Vm sine omega t, d omega t. So after integration and substituting the limits, the V0 will be equal to Vm by 2 pi 1 plus 3 cos alpha. Alpha, it is given as 60 degrees. So 100 by 2 pi. Vm is given as 100. So 100 by 2 pi into 1 plus 3 cos 60 degree will be equal to 39.78 volts. So this is the required answer. 39.78 volts is the required answer. Thank you.